There now, welcome back to the workshop. So on today's episode, I thought I'd bring you along as I strip this Rosengart Type M motor. There's going to be a few interesting things to work out as we go through this motor. As you've probably gathered, this is predominantly a Classic Mini and A Series derivative workshop where that is mostly what I work on. So you guys are going to be with me today as I do a little bit of learning. So I'll be finding my way around. I've literally never seen one of these engines before. The customer brought it into the shop and asked me to take a look at it. So enjoy the journey. Let's go and get learning. So the first thing I think we need to do is to strip off the ancillaries, and then we'll be able to take a deeper look at what puts this motor together. Okay, one of the real lovely things about these Rosengarts is that because they're a French built engine, they are all in metric. So, no looking for any unusual sizes or any kind of crazy tooling. So like I said guys, this for me is a first. I've never stripped one of these before, so everything you're seeing is first-hand real. So it looks like this pulley is just sitting on the end of the shaft. And it is. Okay, so some very interesting engineering straight off the hop here. It's got a cross keyway and then a sort of a turned OD lets it sit on the end of the shaft. So if you look in here, you'll see that we've got the same thing matching in here. And what looks like a bronze seal ring. Okay, let's go a bit deeper. So this is some kind of an integral housing that I suspect is going to house the timing gear. It's a drive for the distributor and may potentially also be an oil pump. I'm not sure. We'll have a look when we see what's in behind this. So anytime I disassemble an engine like this, what I'm interested in is kind of mapping out what's happening as I'm taking it apart. So you'll have heard me say in my last video that I like to do it all with hand tools, and that is because it helps me to take my time and track what I'm doing. That is never going to be more important than when you are taking an engine apart for the first time, especially a motor that you haven't seen before. You will always have an idea of the basic principles because all engines have sort of the same principles. They're going to be some pistons, there are going to be some con rods, there's going to be a crankshaft, there's going to be a camshaft, and there's going to be some way of connecting all those together. But every engine, every manufacturer, every person who builds something is going to have a different approach. They're going to have something different as their way of achieving that. Now, you know, a cursory glance over the engine will tell you a lot. And then after that, you've kind of got to go with your gut and let it tell you what it is you're dealing with or what you might need to do. And I could well find that starting here is not the right place to start. I could well find that I should have started with the sump maybe, or the flywheel or something like that. But you're only going to learn that stuff as you go, as you work your way through the motor. So before we get in with any pry bars or any screwdrivers or anything, we give it a try first by hand. And you can see it wants to come off here by hand. Okay. So what we're starting to see is some of the absolute beauty of Mr. Rosengart, some of the really fantastic engineering that takes place. So we have a helical cut spur gear here, driving a pinion, which is what drives our distributor. It's a really nice piece of engineering. You might wonder, why did I not take the distributor out first? I have the distributor loose so that it was starting to turn, but it was really quite stiff. And I said to myself, there might be something holding this on the inside. So before I go at it, I'll take this off and have a look, and I can see clearly now that it's just a machine boss that's allowed the distributor to turn, and it has a bolt here that I would say goes into a groove of some kind inside. So that will be something we can take apart, but we'll do that on the bench later, and it'll be something that we can deal with at that time. Okay, so we're taking a look here and we're trying to ascertain how this is being held together. What are the major components? So the end goal is to get this steel plate off, this kind of mounting plate that's holding everything. So I think a couple of things that need to go here to get that plate off. We need to get this camshaft drive sprocket off here. But it looks like in order to get that off, we need to get this nut open, and that would be being held by this smaller spigot here, which has like a castellated nut, which looks like it's split open. It looks like the end of the nut is, you drive a punch in and you split it open as a way of holding it. You can kind of see there's a kind of cross section through it. So I'm going to just try a spanner on here and just see, does that nut turn open. Okay, so as we try and loosen this nut, the engine is turning. So we want some way of stopping that from rotating. And generally, the best way of doing that is a bearing shell in the ring gear. So if you come around here, I'm going to show you my little trick. So a bearing shell, I'll come around the other side so you can see a bit easier. If we watch a bearing shell, which way is the engine rotating against loosening this nut? It wants to go that way. So a bearing shell fitting into the teeth here of the ring gear allows us to rotate and lock the flywheel. So the two ends of the bearing shell are fitting in the teeth and are locking up against the housing. So that's a real easy trick if you ever want to get something like that to work for you. So let's just try this nut again and see, can we get it to open? And we are. Get a bit of turn on there. So most important is patience when you're taking a motor apart like this. Spending your time going nice and slowly and working your way along. This is bronze, so we're taking our time here to just make sure that it's not a press fit or anything like that. I'm seeing a little bit of movement. So let's try a crow's foot in here and see, can we get this to move? Yeah, there we go. Okay, that's interesting. So next we want to tap over this lock tab and then we can try that nut. Let's work back this lock tab now. Again, nice and ginger. We want to just work it back until we get it to back there. Get a socket now. We might actually go with a spanner. Yeah, it is 26. Okay, I suspect this is going to be tight. Oh, that wasn't too bad. Now I think this keyway here might have to come out before this nut is going to come off completely. So let's get a little sharp screwdriver and see, can we pick out that keyway. So I always keep a little host of screwdrivers in my toolbox that are old and no good anymore that I can sacrifice hitting with a hammer. But it's a grand, they're very useful for getting little keyways and stuff like that out. So with that nut loose, it should just back off out over here, which it does. And then we have a lock washer on here. Do you want to just slide off? Okay. So I see on this gear 2 threaded holes, which I get the impression might well be for us to pull this gear off. Very interesting is that this gear is actually fibre of some kind. It's some sort of fibre construction. You can see it's not metal. You should be able to hear that there. So that is a wearing component, which still seems to be in relatively good shape. It may well have a steel insert in here, which it does look like it has. And then the outside of the gear is some kind of fibre. Some marks here for timing, so we've got 2 dots there and 1 dot there, so that tells us how we're going to time that up again another stage. So let's just very gingerly see what bolts fit in here, and we might use the slide hammer then to pull the gear off. Everything else on this engine has been metric, so I've a theory that this is going to be metric. So yeah, there's some kind of a metal boss inside there in the middle of that gear. Now let's just try something here. Let's just try turning these in and see, will they just press the gear off by turning them in. Sometimes that can be the case. So I'm just very gingerly winding these bolts in to see if they are pressing the gear off the end of the shaft. And so far they're actually turning in quite simply, so they might well be doing the job for us. If we feel resistance, then we'll stop and try a puller on it. Okay, I'm kind of at the point where I really don't want to screw them in any further. They might well actually just be a blind hole. They may not be all the way through, which would stop the bolt from going through and pulling the gear off. So just give me a moment and I'll do a bit of thinking about this, and then we'll bring you back with a solution. I have a very simple setup here. This is just a piece of fixturing off the milling machine, and I've just wound the 2 bolts in. So the fixturing has a slot across the front of it. It's one bit of it is sitting against the nose of the camshaft, and then we've got the 2 bolts wound into the hole. So as we tighten in these bolts, they're going to try and close that gap there, effectively pulling this gear off. So let's just give that a try and see how it works. So winding this in, and I think I see movement on the gear already. Yep, we definitely have movement there, and that looks good to me. Success. Okay, so very definitely we have a fibre gear and we've got a metal ring. Very interesting here is I can see some witness marks where somebody was in here with a chisel before. Look at that. It's a witness mark there and a witness mark there. So somebody was in here with a chisel trying to force this gear off. Now what we see is we've a taper on this bore, and we've a taper here on the end of the crankshaft. So our methodology was exactly right. We were going to pull against the taper and pop it off. The other person went in here with a big cold chisel, tried to wedge the cam off the camshaft, cam pulley off the camshaft, and definitely have damaged it here. So we'll have to see, can we repair that for the customer and bring it back up to shape. Okay, so we want to get this plate off, and we can see that what's holding this plate on is a couple of these 14mm fasteners here. So they have a 14mm flat, and I'd say they're probably M8 by probably 1.5 or somewhere around that. Interjection here, I've just pulled out one of these spanners. This is called a Dowidat, and it is a made in Germany spanner. So you see here, made in Germany. Dowidat, not so common anymore. I don't even know actually if they make these anymore, but they were a beautiful drop forged chromium vanadium spanner. I have a pretty interesting spanner collection. If anyone ever has an interest in seeing loads of different spanners from all through the years, it's something I collect. Put a comment in the comment section below and I can make maybe a short little video about some of the different kinds of spanners I have, and the different places they came from and the stories behind them. There's some interesting stories behind them. Okay, let's just crack all these with the spanner, and then we will get to, okay, somebody's been in here, because that now is a 13. So that is not an original fastener to this motor. Somebody's been in here and used the 13. So you definitely know somebody's been in this motor before us, because I'm seeing in here blue gasket, cement, smooth stuff, which I am not a fan of at all. So there should be paper gaskets here, and there should be no RTV type gasket sealants, because they just didn't have it at the time. Use the little hand crank, another gorgeous tool. On that, actually, this is a hand crank I have since I was an apprentice. My grandfather gave me this hand crank, and it is by another German make called Walter. I don't know what the German pronunciation for that is. Walter? I don't know. Hopefully we have some German fans on here that'll put me right in my terrible German pronunciation. I do love your tools though. Sorry for wrecking your language. Okay, so we just have this 13 now to get off of here, and then we can see, can we liberate this plate? It's probably just Walter, isn't it? First time I've dropped the spanner today. Alright, we start keeping account of this. Maybe we'll play like a drinking game one of these days. Every time Paul drops a spanner or a tool or a nut in the workshop, you have to take a drink. You'll be locked by the end of this video. Alrighty. Okay, we're nearly there. I think this plate is ready to come off, so I think we'll give it a little tap with the copper hammer and see. It does. It wishes to move. I have to say, I am enamored by the engineering on this engine, because I've just noticed something which I'm going to point out to you now in a second once I get this plate off of here, and it really tickles my fancy. Let's have a zoom in here on this stud, and you can see they've actually made, as part of this stud, a sort of centralizing bushing, or kind of a dowel, I suppose would be the correct term for it. So it's kind of a centralizing one to hold the plate in the right position. Normally you would find two of them. There's the second one there. There you go. So they've got two dowels as part of the studs. That's really nice engineering. Really, really nice. Okay, I think next is we will take off this sump pan. Okay, so something interesting going on here. The last person that was in here used cardboard as a gasket and loads and loads of RTV silicone sealant schmoo. So yeah, we have to get that all off. What we see here is a windage tray. Yet more examples of the really brilliant engineering that was Mr. Rosengart. So this is an oil strainer and windage tray all in one. A windage tray is just basically something that divides the oil from the moving components of the engine, so that the moving components of the engine don't run through actual oil. They're only ever in a mist. It reduces losses. It also reduces churning of the oil, and just gives the engine a little bit of a smoother performance. So we're starting now to get into the guts of it. What we see over here is the oil pump. So this is the oil pumping mechanism for the engine. So I initially had a notion that the oil pump might have been up in this end, but now with the sump off we can clearly see it. The oil pump is on this end of the engine. So get this windage tray out now, and then I think our next protocol is going to be to take the flywheel off. I think that should be our next step forward. So just loosen these off. These fasteners have all been made, and they've all been made on a lathe. I'm just going to try and see if I can get you a shot. Can you see the end of that? The little small sort of tit in the middle of it. So these fasteners would have been turned off of hex bar stock, so they would have had machined 10mm hex bar stock, and they would have put the thread on that side and then parted them off on the lathe. So these were all handmade in a workshop specifically for this engine, not fasteners bought out of mass production like a modern engine would have. Every single fastener in this engine would have been more than likely made specifically for the motor in the engineering works where the engine was made. So you're right at the dawn of sort of mass production of fasteners with this motor. Very interesting. Okay, so let's have a little look in here and see what we have. So this is a very early designed engine, because what you can see here is that the connecting rods here in the middle are on one end of the shaft, and then if I turn the crankshaft 280 degrees, bring up the second set of con rods, and they're then here. So there is only two bearings on this crankshaft, one up this end at the flywheel and one down this end at the timing gear. I'll turn the engine over a bit on its side in a minute so that maybe you guys can get a better look at the timing gear. But yeah, really cool. Another thing that I'm noticing as I start looking at this crankshaft and this engine is it has poured white metal bearings. So these bearings here would have been cast, machined on the end of the crankshaft to the right clearance and then put together. So if you remember back to one of our last mini engine strips, we had the big end of a damaged conrod and bearing shells were separate to the big end, whereas in this case the bearing shell and the big end are all one. It's a poured white metal bearing. Okay, let's get the flywheel off. Okay, I'm not a fan of air tools, but there is certain places where they come in perfectly, and the likes of big flywheel nuts like this, it makes perfect sense. Could I have opened it with a spanner? Yes, but they can be really very tight, and I have a funny sneaking suspicion that this flywheel might also be on a taper. So next thing we have to do is to pull this flywheel off using two sort of spigot bolts to draw it out. So I'll get set up for that. So what I've done here now is I've set up a bit of a puller arrangement. Again, something like the camshaft, a big block of steel, two bolts in there, it's got a slot in it. I ground on the end of this bit of all thread a point, and that point is going to match up with the divot in the nose of the crankshaft. And what I'm hoping here is as I screw this rod up tighter and tighter against this bit of steel, the force of the threaded nut is going to pull the flywheel off the end of the nose of this crank. That's what I'm hoping for anyway. So just kind of wind this against the nose of that. Just want to hit something to hold that. So just keep winding this, and we're building up tension here on these two studs, which we hopefully will get the result of this coming off the taper here. There we go. Okay, so that allowed us to get that flywheel to move back off here. So our flywheel, like we thought, has a taper on the end of it, a taper and a keyway, which matches a taper and keyway on the nose of this crankshaft. So So there's our keyway, and we have a taper on the nose of the crankshaft. Okay, that's the flywheel off. Okay, let's bang back these lock tabs. Oh! Alright, we're going to need some new lock tabs. Let's try this one. There's a bit of steel in this one. Or possibly not. Now, some new lock tabs are definitely going to be required. Wow, they're all just breaking off. Yeah, is there one on that? Already. I would say these are probably going to be 14 as well. Seem to be a very, yeah, good. Get a socket on them. Oh no, they're not that tight. There's something going on here. I think whoever it was used this the last time. Did damage to the head. Let me just see, is there anything we can get at here? I'm not seeing it though. Maybe your little sharp screwdriver might. So this is going to be the same thing again. We're going to be ginger carefully here to get this plate off, because I can see that there is threaded holes in the plate again, which look like there's some form of holes for pullers to go into these two threaded holes here. So let's just see what we get there. So just winding these bolts in here to pull out this steel collar in this casing, and as I wind the bolts in I can see the collar moving out. So they are just acting as a sort of a pullers just by winding them in. I can see the collar is walking out with the bolts as I wind them in. So this collar is obviously a kind of a press fit into the casing. It's the bearing retainer plate. The crankshaft bearing will be in behind this. Just slowly walking this collar out. I'm about to run out of bolt now, so hopefully it's nearly where it needs to be. Let's just try a little pry bearing behind it now. Let's see, can we walk it out the last little bit, which I think we can. Yes, brilliant. Okay, something very interesting here now. It's a taper roller bearing. So here is the taper for the front end of the crankshaft. So thrust is taken up on this crankshaft with a taper roller bearing. So at the other side of this crank will be another taper roller bearing. So the taper rollers are taking thrust and axial load. Okay, so this will have some kind of a shim that's going to set preload between these two bearings. There's a bit of a paper gasket here, which may well be the shim. I'd be suspect that very rarely is a paper gasket a shim, but potentially. We'll go the other end and see what's in behind the other front pulley and see is there a shim that side. So back at the front now, and we're going to have a look, see what's in behind this plate. Now, it may have been prudent to take the pistons out first before this, because once we take this bearing out, the crankshaft will be free floating. And that is what I was saying to you earlier on, that when you become familiar with an engine, you know the order in which to take something apart. And yeah, I feel like maybe having taken out the pistons first now would have been a good idea, but we've committed to this, so we'll take the crankshaft out and then we can have a look at taking out the pistons then. There is things that very much unnerve me as I look into this engine just while I'm taking these bolts out, and I'm going to point them out to you now in a minute. I see nuts in here on the crankshaft that look like they've been from just modern cheap 8.8 M6 fasteners, which would not be up to the job of holding the con rod together. Yeah, let's just see. Okay, very interesting. Again, so what we have here on this end is just a normal roller caged bearing, but there is a spring thrust washer of kinds. So thrust is taken up on this engine solely by a single thrust roller one end. So we're going to have to do some investigation before we put this back together as to how linear thrust is taken up in that taper roller bearing. It's going to be a combination between a clearance set by the flywheel and maybe the torque of the flywheel nut on the taper. It's an unusual setup, so I'm going to have to do a bit of thinking about that and see how clearance is taken up there. So yeah, we have to try and get this roller bearing out now, which I think I'm going to just be able to tap out from this side when I get the pistons out. So I think pistons out next. Okay, let's open these conrod bolts and see what size we have on here. Now to get this crankshaft out, we've just tapped the bearings off either end, so the taper roller off this end, and we've taken out the straight bearing off this end. And now basically what it looks like is this has to go through this hole, and then some orientation is going to twist this around. Yeah, that's looking good. Twist that a bit. Okay, so kind of have to wind this shaft out, it seems, to get it to some way. I wish I had somebody here with me who was good at Tetris. There's some way it comes out of here. It went in here. I feel like that needs to come past there. And then it'll pop out. Ah, maybe you have to have the camshaft out. That might be what it is. Okay, let's get the camshaft out and try again. So to get this crankshaft out, I think I figured it. What we need to do is we need to separate the aluminium block from the cast iron block. So the way this Rosengart is built is the pistons are running in a cast iron block, and the valve train also, because this is a side valve engine, runs in the block. In order to get the camshaft out, it's running in the aluminium block. If we can lift this aluminium block off, it'll take the pressure off the camshaft. I should be able to slide that out, and then the crankshaft can come out, and then the only thing to be stripped then will be the side valve portion of the engine block, which we'll do when we're going to overhaul this valve portion of the engine block. So I have taken out pretty much all the fasteners. I just have one bolt here left which seems to be the last fastener holding the aluminium block. I've had a good cursory glance inside here, and I really don't see any other fasteners that could be holding it. So there might just be one here over this side, and then I think the block is going to lift up. Yeah, there's just one here, I think. So they're a very unusually designed engine. They have some intricacies. There's definitely been somebody else in here before. There's different nuts and bolts in places that they don't match any of the other nuts and bolts in the engine. So that makes me think that somebody certainly was in here before working on this engine, which would make sense, you know. The engine's over 100 years old, so. Is it 100 years? Yeah, I think it is. What is it now? 20, yeah. This is, no, hang on. That's bad maths. It's not 100 years old, but nearly 100 years. So, I suppose it's bound to have had a bit of maintenance over the years. Now, our last fastener is coming loose here. I don't see anything else. So this should mean the aluminium block section should lift off the cast iron section, and all we need to do then is pop out the camshaft, and then the crankshaft could come out. We'll have this engine broke down. Okay, so we can see our camshaft in here, and something is holding it. Could be this, or I also see a sort of crosshead screw here. So I suppose we'll try this one first. I feel like that's an oil gallery plug, but it may well be holding it. It could be a detent of some kind. Let's just see what's under this. Yeah. So it doesn't look like that is it, but that certainly is some kind of detent. Let's just see what's under that. Let's just try the impact on this. Yeah, perfect. So it's another gallery plug of some kind. I'm not sure that's what's holding it. There could be a case for there being a bearing that has to be tapped out with it. That could be the case. Let's just see what we see here. Ah, okay. So we have like a little retaining ring here, I think. So we have our camshaft coming out now, and we can see that we were right. It was a detent. So that bolt that was screwing through the aluminium was screwing in and matching with that hole, and that was retaining this bronze bearing here, which is the bearing, the front bearing for the camshaft. So when we retracted that bolt, we were able to drive the bearing out from the back side here of the camshaft and drift the camshaft and bearing out all as one unit. Which means now we have the beautiful, pretty little camshaft. Now let's see, can we get the crank out? So I think we had gotten as far as needing that to go over there, and then this to come up this side. It's all very close. Aha! It goes through this way. Or does it? It does, it does. Okay. We got the crankshaft out. That's cool. So it sort of serpentines its way into the hole in the front half. And then we can see our oil pump. And down here. So this is the oil pump, and then it has a big jack shaft going all the way down that runs off the camshaft. Okay, well that's that. Okay, I hope you enjoyed coming along with us for the strip of this Rosengart. We still have a very small little bit of stripping to do in the form of the valve and cam follower arrangement here at the top of the engine. But I intend on stripping that when I'm going to actually overhaul this block and side valve arrangement. So this block and side valve arrangement is going to need the valves being reseated and the bores honed on the engine block, because this engine got some water in, so there's some rust and pitting on the engine block. Now the hope is that the pistons are going to be savable, and we have already sourced a set of rings for the piston from a French website, so we think we can just literally hone these bores, clean up the valves, and we can put this motor back together. We have some measuring and checking to do like always. But yeah, hopefully you enjoyed that. If you did enjoy the video, maybe give us a like. And if you're new to the channel, you're really very welcome. If you want to subscribe to see loads more content like this and keep being updated at the next step or the next process as it comes out. Other than that, guys, thanks very much for watching, and I'll see you on the next one.